Hey everybody, Joe Piezinski from Advanced Innovations in Austin, Texas. I want to say thank you and welcome to all my new subscribers. I am overwhelmed with the response. Coming up on 1,000 subscribers. I never imagined it would get there. Never imagined I'd have 100 subscribers, let alone 1,000. So thank you very much for your confidence. Thank you for watching. Thank you for all your good comments and positive feedback. It keeps me motivated. Today we're going to go over on the mill and talk about how to hold your workpiece. I saw some videos online of some things that people were struggling a little bit. Now every situation is different. Everybody has their own environment and tools and things that they can use and not. But I'm going to show you what I do, and I take it for granted, and if it can help you make your setup a little bit easier, quicker, solve a problem, then it was worth it. All right, let's take a walk over to the mill and check it out. All right guys, so today I'm going to talk about some of the most basic stuff in machine shop. It's just putting your part in a vise. I think everybody puts their parallels against the jaws like this, closes the jaws down, and this is actually what inspired this video in the first place. I watched someone having a little bit of difficulty doing this. Wonderful, you got the part down, you tap it down if it's your second side, whatever you got to do, and when you open it up, oh, lo and behold, that back parallel starts to fall down. Well, there's a million different solutions, but I'll show you the one that I use, and I use it quite regularly. Springs. Stick a spring in here. Now every time the jaw is spread, it's like those parallels are part of the jaw. There's 1,000 different kinds of springs. You can get them at a hardware store, you can find them laying around the house, whatever. Stick a spring in there. If that doesn't do it for you, there's a different kind of spring you can use. This type of spring, made out of a piece of strapping from a pallet from a machine that got delivered. I took the strapping off of it, chopped it up into little pieces, and now I have springs. I'll take it, you can bend it however you want, stick that in there. There you go, it's a spring. So your piece is too big and this doesn't go far enough. Wonderful. Let's open up the jaws and just assume that that's a fact. Stick a block in there and then stick your spring in there. Okay, you can do this as much as you want, and you can have an 8-inch opening if you want and still have spring-loaded parallels. Another thing you need to be concerned with, that I am quite often, is when you get chips built up in this area right here, and you go to sit your part in there, and it's actually sitting up on the chip. You want to eliminate that problem? Take another parallel, stick it down behind the one that you're going to be banking on. Now you have a trough right here, and when you blow it out, this is the only surface you need to be concerned with, along with the back, because if any chips stay behind, they're probably down in the trough, and now the part is nice and clean and the confidence level is much higher. Let's assume you have a part that's too narrow to hold on a parallel, because when you close the vise, you just run out of room before the vise squeezes your part. How do you overcome that? Let's take a look. Let's say there's your part. What I like to do, and I've been doing for years, take a couple of more parallels, a couple of big tool bits, a piece of scrap stock, whatever you got laying around, and build yourself a bridge on the back side. I'm going to use the spring-loaded shim stock again. Close it up. Now you're probably saying, what good is that? Guess what? When you lay another bar in there, preferably higher than the existing parallel in the back, look at that. You can squeeze your fingernail in there if you wanted to. It doesn't matter how thin your part is, you can still hold it. Pretty good, right? Alright, let's talk stops. You want to put those parts in and out of that machine all day? Make yourself one of these, little piece of 1-inch by 1/2 inch, 1.25 inch long, 1032 set screws. Chop it out, lock it down, boom. Now you're going to say, but I still can't squeeze it. So offset this and offset this. So now you have a functional stop and a small part, and you got the problem solved. I like vice stops, but they're not always practical. Let's imagine you have a much larger piece and you have one of these neat little guys tied to your vise in the back. I bend my rods like this for a specific reason. And I'll lock it down. I'm going to show you what that reason is. My rods are bent like that so that if I have a part in the machine that I'm trying to deck off and clean up, I don't want to have to worry about the fly cutter banging into anything. You deck across the top of that part, everything is out of the way, and it's easily achieved by just bending your rod. Simple. Alright, now we all know that you don't always get to have perfectly square stock or stock that can be held rather easily. Like this nightmare right here. Could you imagine if someone asked you to drill a hole in that or a slot? I mean, where do you hold it? If you squeeze it this way, which surface is it going to go to? This one or this one? I mean, it's a trapezoid from another planet. It's really bad. So this is how I would address a problem like this. If you have a flat surface, which you're going to have a flat surface, you can use one of two little things. You can use a ball with a flat on it, or you can use a cylinder with a flat on it, depending. Put your part in here. Put the flat side of the ball against the part, and when you squeeze it, it really doesn't matter if the sides are out of parallel or out of square or whatever, because you have tangent point contact here. The flat on the ball is registered tight against the plane, and the part is registered tight against the vice jaw. Now, if you're doing this for an initial cut, I would highly recommend that your first pass or any heavy pass be in a clockwise rotation that drives the part against the stationary jaw, because you have more surface contact. Once you start to establish square sides, you can then go to conventional clamping. The cylinder works very well as well. If you have a surface that may not be compatible with the ball, when you have a cylinder, right now you have tangent contact, but as you rotate that cylinder, you're going to have linear contact. Now, this is something that the camera is really not going to do justice to, but as you rotate that cylinder, the back side of the cylinder bounces around and ultimately will form a parallel line with the back surface. You got to try it. It's a great trick. You can also reverse this. If you have a part that's tapered this way, you can reverse it and the flat will take up the slack and you have a nice grip right there. Easy. Let's say you have a part that's too small for the majority of these setups and you can't hold it anyway because you can't get the stop in there because everything comes down and crushes your part. Make a nest. Something stupid and simple. Take your stop, bring your stop in, bump on the nest, and then build your bridge again that I just showed you a minute ago. Now you have a nest for your part without a soft jaw against the stop, and it doesn't matter how thick that piece is, you're going to come in and you're going to squash it against the back of the machine. Alright, one more thing. In closing, if you have to use an angle block against the stop, like these wonderful angle blocks that you can probably find a video on how to make, just a guess. If you put your part in here and you have to locate your part against that angle block, you don't want to have to push the angle block against your stop and push the part against the angle block. Make sure that all your motion is in the same direction. So as your part drives down against its registration point in your stop, as you push that, the whole thing slides and bumps up against the stop. It's a one-finger guarantee, and when you bring the vise closed, you should be somewhere close to what you think you're going to achieve. And that's all I got for you guys. Springs, balls, parallels, spacers, angle blocks, cylinders with flats on them. You pick which one works out for you. Give it a shot. I hope you found something here. All right, well, that's all I got for you. I hope that you saw something that you can utilize in your own shop. Sometimes it's not really hard to do whatever's required to the part, drill it, slide it, mill it down, but sometimes it's a little difficult to figure out how to hold it, right? Next time around, in the near future, I'll take you over to the lathe. I'll show you how to hold exceptionally thin wall material without distorting it, crushing it, or causing any damage. Thank you once again to all my subscribers, new and past. Wonderful. Love the feedback. Love the little subliminal message going on here. Keep the comments coming. It keeps me motivated. If you have a question, if I can answer it, I will. And there's a lot of questions out there, so if I can get to you, please hang in there, and I will get to you. Thank you again. Till I speak to you again. Joe Pazinski, Advanced Innovations, Austin, Texas. I'm out.